All right, I need you to grab your Frere model worksheet and take that out because we are going to add the last two rules to that today. We're going to add the negative and the zero rules. So pause this until you have that worksheet out in front of you, and then you can go ahead and start it again. We're going to start with the negative rule. So, sorry, I lied. Apparently we're starting with the zero rule. So go ahead and write zero rule in the middle of your next available Frere model. And we're going to talk about what that might look like first within a problem. So if you see the same base on the top and the bottom of a fraction with the exact same exponent, then that is going to end up applying to the zero rule. The other thing that you might see is you might just see a base with an exponent of 0. So take a second to write that down, pause if you need to, and then as an example, what that's going to look like is this. So the fraction with the same base on the top and the bottom, here I have written x to the fourth over x to the fourth, and here, or that could look like just x to the 0 power. So if you see either of these two things, then you know that the zero rule is being applied. Hop to the right now. We're going to do our expansion over in this box. So the problem that we're going to expand is m to the 6th over m to the 6th. So what I write out is 6m's being multiplied on the top and 6m's being multiplied on the bottom. Now, what you're going to notice is you can make 1's out of all of those m's that are on top of each other. So you're going to see me do that here, 1, 1, 1, 1, 1, 1. And as I'm multiplying all of those together, 1 times 1 times 1 times 1 times 1, all that's left is just 1. Okay? You can also think about this using the quotient rule from the last target, where I took m to the 6 over m to the 6 and subtracted those exponents, and that would just be m to the 0, which again is just 1. Okay, so let's put that idea, that rule into words down in the left side. So in words, anything to the 0 power equals 1. So that could be a million to the 0 power, that could be negative 12 to the 0 power, any fraction to the 0 power, doesn't matter what that base is, anything to the 0 power equals 1. So this is going to feel silly, but let's do some examples. The first example I have there is just 4 to the 0 power is 1. With a number base, works the same. The next example you're going to see is x to the 5th over x to the 5th. Again, using that quotient rule, that's the same thing as x to the 0, which is 1. And here I just start with m to the 0, and that equals 1. This is a pretty boring rule, but it should be an easy one to get down. Okay? If you need a second to pause and make sure you have all that written down, go ahead and do that. Otherwise, I am moving on now to the negative rule. Alright, so add that into the center of this should hopefully be your last model, if you did everything in the right order. Go ahead and write negative in the middle. And let me show you in the top left side what those problems are going to look like. So you might see a fraction with a higher exponent in the denominator than in the numerator, because that will create a negative when we subtract those. Or you might see just a base that has a negative exponent. So those tend to look like this. Either this one says p to the 5th over p to the 8th, that's going to result in a negative, or here p to the negative 3rd. And you should have seen in the intro worksheet and the little video from before that those turn into fraction exponents, and we'll talk about that in a second. Let's do an expansion. Okay, so if I expand x to the 3rd over x to the 5th, I put 3 x's on the top and 5 on the bottom. And then I can start to make 1's out of that. So you're going to see I can make 3 1's on top. And then that ends up with just here, I have 2 left over on the bottom. And so that's the same thing as 1 over x squared. Okay, so this, if I had subtracted with the quotient rule, would have ended up at x to the negative 2, and these two things are the same. So what you're going to notice is I can take this, I can flip it, write the reciprocal, I can flip it in the denominator, and then I can make that 2, I can switch it from a negative 2 to a positive 2. So let's write that rule down here. It says write the reciprocal of your fraction and then switch your exponent to positive. Okay, so an example might be 1 over y to the negative 2 power. I write the reciprocal, meaning I flip this from the bottom to the top, and then I change that negative 2 to a positive 2 to be y squared. Okay, another example we might do would be 2m to the negative 3rd. Now this 2 here has an invisible 1 exponent that we just don't write because we're lazy. So that 2 has to stay on the top of your fraction. The only thing that moves down into the denominator is this m to the negative 3rd. So this, as I write it, would be 2 over m to the third. Now that's a common mistake I see, so make sure that you maybe put a circle or a star by that example so that you don't make the mistake of bringing the 2 down with it. Okay, the 2's got to stay on top because of that invisible 1 exponent. Okay, last example, we could have 3 to the 4th over 3 to the 6th, and if I subtract using that quotient rule, that would give me 3 to the negative 2. I flip that into the denominator, giving me 1 over 3 squared. And then whenever I have a number base like that, I want to actually multiply it out because I know that 3 squared is the same thing as 9. So I'm going to write 1 over 3 squared as 1/9. Okay, if you need a second to get any of that down, go ahead and pause here, then we're going to do some examples. Okay. You might need to grab another sheet of paper to write this on, so if you need to do that, go ahead and take a second to grab a piece of notebook paper or a classwork notebook because you don't have a lot of extra space there on that Frere model worksheet that you have. Okay, the first example we're going to do together is just k to the negative 5th, and I'm going to simplify that and write it without a negative exponent, and that would give me 1 over k to the 5th. Okay, second example we're going to do is going to be x to the negative 2 times x to the 5th. The first thing I can do is I can take this x to the negative 2nd power and flip it into the denominator. That gives me x to the 5th over x squared. And then I use that quotient rule to subtract 5 minus 2, and that gives me x to the 3rd power. That's totally simplified now. All my exponents are positive, and I'm down to just one base. So that's good. Okay. Next example is going to be y to the negative 2nd over y to the negative 3rd. First thing I'm going to do is flip both of those. So this comes down to the denominator, this goes up to the numerator, and they both become positive. So that flips to y to the 3rd over y squared. And then I can use my quotient rule from the last target to subtract those and just get y. Okay, let's do another example. 3 to the 4th times 3 to the 0 times 3 to the negative 2. First thing I'm going to do is I'm going to change this 3 to the 0 power to just be a 1. Okay, so that's just a 1 now. And then the next thing I'm going to do is I'm going to take this 3 to the negative 2nd power and flip it into the denominator using my negative rule. Then I'm going to subtract 4 minus 2 to get 3 squared. And again, when I have that number base, I want to actually take it and write it as a 9 because I can simplify it more than just 3 squared. My final answer should be 9. Okay? You're going to try a couple examples now. Go ahead and pause the video and try and simplify these down as much as you can to just get one base and get rid of all of those negatives. Try and simplify those down as far as you can using all 5 rules. Keep that Frere model sheet out so you can use that to help you. And then restart this video when you're ready to check those 5 problems. Make sure you got them right. Alright, take a second, check your answers. The first one should be 1 over x to the 6th. Second one, all that flipped down into the denominator, 1 over a squared b. The third one, the x to the negative first flipped up and just became x. And then my fourth one, I did a lot of simplifying there, ended up with just 7 squared, which is 49. And the very last one should be 1, because 8 to the 0 power is just 1 over 64. Okay, your exit ticket to get out of this video is to try to simplify this problem. It's going to use all of the rules that we've done so far, and your answer when you're done should not have any negative exponents. If you have negative exponents, you're not done still, okay? So take a second, pause. This problem tests everything that we've done so far, and then go ahead and restart it when you're ready to check. Hopefully you ended up with just 1/2. You can simplify 3/6 to 1/2. Just one y on the top and an x squared on the bottom. If you did not get that, come raise your hand, ask your teacher, figure out what went wrong, but try and figure out where you went wrong so that you don't make those mistakes on your practice.